Hi everybody, welcome back. Today we're going to be discussing the integumentary system. The integumentary system has many different functions. First, the skin protects you and your body from the outside world. Intact skin does a really good job of keeping out things that shouldn't be in your body. It also protects you from water loss. The skin is also home to many types of sensory receptors. Anytime you touch something or something touches you, receptors in the skin send information about that type of touch to the brain. We have receptors that tell us the difference between a tiny tickling touch and deep pressure. We have receptors that tell us about the temperature of a cup we are holding. We also have receptors that tell us the texture of a surface, so we can discriminate between smooth and rough, soft and hard. The skin is also important in maintaining temperature homeostasis. Remember that an organ is made out of two or more types of tissues working together. The skin has several different types of tissues working together, so it qualifies as an organ. There are two layers that make up the skin. The top layer is the epidermis, and it is made out of stratified squamous epithelium. The layer underneath it is the dermis, and it is made out of fibrous connective tissue. This is the layer that contains the blood vessels, sensory receptors, and glands of the skin. Looking more closely at the epidermis, you can see the many layers of stratified squamous epithelium that make up the epidermis. The superficial layer is the part you see on the outside of the body. As you walk around and brush up against your surroundings, the top layer of the epidermis is constantly being shed. The layers are replaced from underneath. A single layer of stem cells at the bottom of the epidermis divide, constantly creating new skin cells that are pushed up into the epidermis to replace layers that are lost at the top. The cells of the epidermis are called keratinocytes, and they produce the protein keratin. As the keratinocytes move further away from the blood supply of the dermis, the accumulation of keratin causes them to harden, and they eventually die. This accumulation of protein and the buildup of dead cells creates a waterproof layer that protects against fluid loss and foreign invaders. Therefore, the outer layer of your skin and your hair and your nails are all made up of dead keratinocytes. Also present in this layer are cells called melanocytes. These cells produce a dark pigment called melanin. This pigment protects the stem cells from damaging UV light. The darkening of your skin after a day at the beach is the result of increased melanin production by the melanocytes and signals that UV damage has occurred. All people have the same number of melanocytes in the epidermis. The differences in skin color we see are due to the amount of melanin produced. Darker-skinned people produce more melanin, and lighter-skinned people produce less melanin. The accumulation of UV damage can lead to skin cancer. Basal cell carcinoma is the most common type of skin cancer. This is where the stem cells of the epidermis start growing uncontrollably. Melanoma is a far deadlier type of skin cancer and is the result of the melanocytes in the epidermis growing out of control. We also have special immune system cells in the epidermis. These are called Langerhans cells, and they are macrophages that move about the epidermis and survey for any foreign invaders. The dermis is made of fibrous connective tissue, which contains collagen and elastin fibers. These fibers not only allow the dermis to stretch in many different directions, they also keep it firm, and the epidermis laying on top is smooth. As you age, you produce less collagen and elastin fibers, so the dermis loses its firmness and begins to sag. This forms wrinkles in the overlying epidermis. Many of the sensory receptors for pain, touch, temperature, and pressure are found in the dermis. Although the hair shaft can be seen above the surface of the skin, the hair actually grows from epithelial cells in the hair root of the dermis. You can see the hair root here. Also associated with the hair root is a gland called a sebaceous gland. This gland secretes an oil called sebum. The sebaceous gland secretes the sebum into the hair follicle to protect and coat the hair shaft as it leaves the dermis. Overproduction of sebum can cause a blockage in the hair follicle. When this happens, a whitehead is formed. Acne is when immune cells cause inflammation in a blocked hair follicle, resulting in red and painful swelling and the formation of pus or dead skin cells. Another structure associated with the hair root is the erector pili muscle. This tiny involuntary muscle will pull on the hair root, causing it to sit more upright in the dermis. This makes the associated hair stand up on end. This muscle is activated in times of fear or to help with thermoregulation. You can see an example of the erector pili muscle in action if you ever watch a cat squaring off with another animal. The cat will exhibit the classic fight or flight response, which causes the erector pili muscles to pull on the hair root and causing the fur on the cat to stand up on end. This makes the cat look bigger and hopefully will scare off his enemy. The erector pili muscle also contracts when we are cold. In animals, this allows their fur to stand on end and create a layer of warmth around their body. In humans, we don't have enough body hair for either of these techniques to be effective, but our erector pili muscles still react in times of fear or cold. If you have ever been walking through a sketchy parking garage and felt the hairs on the back of your neck stand up, that is a fight or flight response causing the erector pili muscles to contract. In addition, if you're cold, you might see goosebumps on your skin, which is the hairs on your body trying to stand up warm and create an area of warmed air around the skin. Another gland in the dermis is the sweat gland. This gland produces sweat, which is released into a duct that opens onto the surface of the body through a sweat pore. Evaporation of sweat helps to cool us off and maintain temperature homeostasis. Another way we maintain a constant body temperature is by increasing or decreasing blood flow to the skin. When we are too hot, the blood vessels in the skin can dilate, bringing more blood to the surface of the body, where we can cool it off and allow it to lose heat to the cooler environment. This is why you might appear flushed and red-faced after working out. Your body is trying to dissipate heat that you created from using your skeletal muscles. When we're too cold, these same vessels constrict, reducing blood flow to the extremities and maintaining temperature by not allowing as much contact with the environment. In extreme cases, people can lose fingers and toes after hypothermia. In maintaining internal temperature, we reduce blood flow to the extremities so much these tissues might die due to lack of blood flow. The layer of adipose tissue under the dermis is called the subcutaneous layer. It is not technically part of the skin, but it shares some functions with the skin. This layer helps to insulate us and attach the dermis to the underlying muscle. Oftentimes, we use a hypodermic needle to deliver injections to this layer. The nails are an accessory organ of the skin. Their job is to protect the digits. The nails grow from epithelial cells at the base of the nail, in the portion called the nail root. The cuticle is a fold of skin that protects the nail root. Cells become keratinized and die as they grow out over the nail bed, forming a tough, hardened, and waterproof nail. That's it for today. See you in class.